Question number 116. Phenylketonuria is first option, an example of pleiotropy. Second, an autosomal dominant disorder. Third, related to the mutation of multiple genes. Fourth, an X-linked dominant disorder. In case of phenylketonuria, what happens? There is a mutation in the gene which is responsible for the synthesis of an enzyme called phenylalanine hydroxylase. When there is mutation in this gene which is responsible for the synthesis of this enzyme, then there will be no synthesis of this enzyme. This enzyme is responsible for the conversion of phenylalanine into tyrosine. Then, due to absence of this enzyme, there will be accumulation of phenylalanine in the body. So, it is related to the mutation of multiple genes? No, it is related to the mutation of a single gene that is responsible for the synthesis of phenylalanine hydroxylase. It is X-linked dominant disorder? No, it is autosomal recessive disorder. So these two options are ruled out. First is an example of pleiotropy. Yes, phenylketonuria is an example of pleiotropy because due to accumulation of phenylalanine in the body, there are multiple effects. What is pleiotropy? Pleiotropy is a condition when a single gene product can control more than one effect. So the correct option for the given question is option number 1. Let's move to the next question. Question number 117. Identify the following statements as true or false and select the correct option. A. Failure of segregation of homologous chromosomes during cell division leads to aneuploidy. B. Polyploidy is more common in plants. C. Non-hemophilic parents cannot have a hemophilic child. So, failure of segregation of homologous chromosomes. When homologous chromosomes are unable to separate from each other during the cell division, then they lead to a condition called aneuploidy. This is correct. B. Polyploidy is more common in plants. Yes, polyploidy is more common in plants as compared to the animals. C. Non-hemophilic parents cannot have a hemophilic child. This is false. Why? For example, if you consider the parents, the mother is carrier for the disease but not hemophilic, and father is absolutely normal. So both parents are normal, but the mother is having the trait, but it is normal. Now the offsprings can be XH, X, XH, Y, XX, the last is X, Y. So both parents are normal, but they can have a hemophilic child over here. So this is hemophilic son. Rest 3 children are normal. So the correct option for the given question is option number 3. Let's move on to the next question. Question number 118. How many alleles determine the skin color in human beings? First option 3, second 6, third 4th, fourth 2. In case of humans, the skin color is controlled by polygenes, and 3 pairs of polygenes control the skin color. So if it is 3 pairs of genes, it means 6 alleles in total controls the skin color in a human being. So the correct option for the given question is option number 2. Let's move to the next question. Question number 119. Study the following pedigree chart and choose the correct option regarding it. First option, it is not applicable for an X-linked recessive disorder. Second, the genotype of A can be XCX. Third, it shows inheritance of a Y-linked disorder. Fourth, the genotype of B cannot be small a. So study this pedigree and choose the correct option. First option is it is not applicable for an X-linked recessive disorder. It can be applicable, but you have to check for it. If this disorder is X-linked recessive, this should be XCY and the female should be XCX. Female can be normal also. Now, in this generation, which is written as second, if this female is affected, it means its mother should be heterozygous, not the homozygous. For this should be the genotype for the mother. So, genotype of this female will be XCXC. So, one XC comes from this mother and one XC from the father. This female is a normal. In this case, XC comes from father and one X chromosome from mother. This is affected means XC is coming from mother and Y from father. This male is a normal. It means X normal chromosome is coming from mother and Y from father. Now, this person should have the genotype which is XY. This male is a normal. It means X is receiving for the mother and Y from father. And this is receiving XC from mother and Y from father. And they receive both of them X from mother and X from father, which is quite normal. Yes, then it can be applicable for X-linked recessive disorder. So this option is ruled out. The genotype of A can be XCX. Yes, the genotype of this A can be XCX. This is correct. Third, it shows inheritance of a Y-linked disorder. No, because Y-linked disorder transfers in every generation from male to male, not from male to female. But here, B is a male who is suffering and it is transferring the disease in the second female. So, it is not possible. Fourth one, the genotype of B cannot be AA. This pedigree chart is also true for autosomal recessive disorder, and in that condition B can be homozygous recessive for the disorder. So this option is also ruled out. So the correct option for the given question is option number 2. Let's move to the next question. Question number 120. Which among the given enzymes is not composed of RNA? First option, ribonuclease P. Second, SNP. Third, RNA polymerase. Fourth, peptidyl transferase. Ribonuclease P, SNPs and the peptidyl transferase, these all are ribozymes. They are composed of RNA, but RNA polymerase is a proteinaceous enzyme. It is made up of proteins, not with the RNA. So the correct option for the given question is option number 3. Let's move on to the next question.